Hello everyone, welcome to the course Animal Waste Management with the module name Animal Waste and Environment, Week 4, Lecture number 2, with the title Economics of Farm Waste Handling and Utilization. Today we are going to discuss that as the population of our earth, of our globe is increasing day by day, the demand for the energy is also increasing in the sequence of the population increase, and we are getting depleted with our. So here we see, as we are getting increase in the number of population, we are observing here that the number of human being in our globe is increasing day by day. Means with the increase of the population, the demand for the energy is also increasing, and we are getting scarce for our cheap resources of energy. Right now, we are getting depleted in our conventional resources of energy like petroleum product, like coal, like wood and everything, just because of the deforestation and the concrete jungle what we are increasing day by day. Our energy resources are depleting, so there is now need to shift for some other resources. Likewise, we can say that some non-conventional resources of energy. Here we see that we are having two kinds of energy resources. The first one is conventional and the second one is non-conventional resources of energy. If we talk about the conventional sources of energy, then we see again two bifurcation, that commercial and non-commercial. Under the commercial one, that are we are actually dependent upon that right now, that this is covering coal, petroleum and electricity. While the firewood, straw and dried dung is used in villages in rural regions, while the non-conventional sources, which are very less used by our population, that are bioenergy, solar energy, wind energy, tidal energy, but we are very sure that if we can shift from conventional to non-conventional resources, then certainly we are going to get lesser dependent on these conventional sources of energy. Here we are having a wonderful option that we can convert the waste out of our agriculture, entrepreneur and animal husbandry, just in the format of some kind of heat and other energy resources and the power supply with the use of the waste only. So here, for example, we are going to deal with today the economics of the production, handling and utilization of biogas, which is a very good source of non-conventional resources of energy. So here we see that the raw material for the biogas is the animal and human excreta and agricultural waste, with the primary material in India, which is the cattle dung, that the bovine excretory material. Here we see that the biogas is the fourth largest energy source globally, which can provide that 13% of the total energy, 55 EJ per year. Here I would like to tell something about the term EJ. EJ is just known as exajoule. This is exajoule. Exajoule means this is equivalent to 10 to the power 18 joules. So just to have a look on this EJ concept, is that the total energy consumption of a country is measured on this EJ. So ultimately for US, you can say that right now US is consuming around 95 EJ energy, while India is consuming around 38 EJ. So here how we can create the association or link that how much energy demand is increasing day by day, and how the countries are different, how the developed nations and developing nations are having the differences for their energy consumption. Here, if we are concerned with the India biogas potential, we see that as per the 20th livestock census happened in 2019, we see that the cattle population in India is around 192 million, while the buffalo population is around 1 to 9 million population, so making it around 300 million population of cattle and buffalo, which can produce around 980 million tons of dung annually, which can generate the 195 billion kilowatt hour of energy per year. If we talk about, and if we are converting this 195 billion kilowatt hour of energy per year, it will be coming around 0.7 or you can say 0.8, means in between these two figures we can convert out of this dung produced of our 300 million bovine population. So here we see that from where we can get the raw material for our biogas. So ultimately we see that our bovine population is investing much in this, like buffalo population, cattle population, along with this goat and sheep and pigs also. These are producing some manure in the form of the excretory material, and after putting these manure excretory material in anaerobic digester, here from the digester itself, the slurry thereafter we can put into our field and use as biofertilizer, while the biogas evolved from this digester can be used directly as heat in cooking, and after that electricity. After some refinement, it can also be converted into biomethane, which in turn is a type of biofuel, and it can also be transported to some gas grid, from where it can be transported further for where it is better be used. Along with this, ultimately we are saying that the greenhouse gases is being reduced by using the manure obtained from the bovine population in the form of dung, excretory material, agricultural waste, urine and other things. And thereafter, if we are putting the biofertilizer produced out of these things, then the crop production will also get on hike. So we are going to have a sustained agricultural system if we are using this manure in the form of biogas plant. So how biogas plant is beneficial to us, we will be dealing the same concept in an example with the assumptions. Right now we are seeing that how many types of costs are involved in installing a biogas plant here. So we see here that installation cost, which is the initial investment, and subsidies and grants which can be provided by some government agencies like CREDA in Chhattisgarh actually, and may offer some kind of financial assistance. Initial investment is the total cost which include the land, construction and the construction material for the construction of that biogas plant. The next one is the fixed cost which include the depreciation, interest and repair and maintenance. Depreciation, what is this? That this is the calculation based on the plant installation cost and the lifespan that is treated here and assumed here as 20 years, and the residual value means we are talking about the junk value. This residual value is junk value, means after that 20 years period, what will be the total value of that installed biogas plant. So here we can see that the residual value is the junk value of that biogas plant after spending that 20 years of lifespan. So this depreciation reflects the annual reduction in the asset value. So if we are treating it as that, if we are considering that 50,000 rupees is the total cost of installation, then every year, and the life of that biogas plant is 20 years, then we can say that every year some parts of this 50 years will be depleted and the value of that thing will decrease as per the year increases. So, and thereafter here we are seeing that interest, the cost of financing the installation, typically assuming that 10% annually. The repair and maintenance, which is very essential things for biogas plant, because there is always some kind of wear and tear in this. So here we see that periodic expenses to keep the plant in operational condition, the repair and maintenance cost will be needed. Thereafter, the operational cost, that will include the labor cost and the raw material and some kind of other utilities. So here you can see that thereafter we are getting some output in the form of gas output and some saving, and thereafter electricity generation out of that gas. So thereafter we will be calculating the economical viability matrix with the significant payback period and cost per unit of energy, and thereafter in form of annual saving. So here we are assuming something like plant size. Here we are dealing with 2 meter cube per day capacity, means that gas production will be 2 meter cube per day. Installation cost, here we see that 50,000 rupees will be there, which include the material, the labor for installation itself and the land preparation. Thereafter, the working hours per day, here we are assuming that 6 hours per day will be the working hours in daily basis. Thereafter, the plant life, it will be treated as 20 years. the junk value will be 10 years of the installation cost. Means 50,000 we have taken, and now the 10% of this, that 5,000 will be remained after spending that 20 years of life. And thereafter the annual working hours, what will be the annual working hour? That's 6 hours daily and 365 days in a year. So in a year 365 days will be there, and 6 hours daily we are working. So 2190 hours per year we can assume that will be the annual working hour. Interest rate if we talk about, then it is just 10% annually. And the dung feed rate, that for that capacity of biogas plant 25 kg per day, that 10 kg produces 1 meter cube of the biogas. So here we can say that 2 meter cube per day capacity can be produced if we are feeding with 25 kg per day in a rough sense. And thereafter the dung cost, here we are taking it as 1 rupees per kg dung cost. And the repair and maintenance, that will be charged as 500 rupees. Here we are taking it 500 rupees per year. Now coming to the calculation part, that the fixed cost which is covering the depreciation, interest and some maintenance one. So the first is depreciation. So what is depreciation actually? Depreciation is that the cost for installation, and thereafter this J is the junk value. So the installation cost and minus junk value by the total life of that biogas plant, and thereafter the hours in a year. The working hours in a year, that is 2190 hours, and 20 years of the life, 50,000 rupees the installation cost and 5,000 rupees is the junk value. So ultimately we are coming as 1 rupees 1.03, to be very precise, 1.03 rupees per hour. This will be the depreciation. So everything whatever we are calculating here will be coming as rupees per hour unit. So interest rate, that interest rate is basically this one, and the interest in the form of rupees per hour. Just to calculate this, here we see that the C, as you all know, that the installation cost, and thereafter the junk value, and thereafter this H is the annual working hours. Here we see that 50,000 was our installation cost, 5,000 rupees was our junk value, then this H is the working hours annually, and thereafter this comes as 1.26 rupees per hour. This will be the interest on hourly basis. So what about the repair and maintenance? Here we see that what we have assumed earlier, that the annual cost will be rupees 500 per year. So putting it in hours, as we are already knowing that in a year that 2190 hours will be there as 6 hours in a day. So ultimately 6 hours in a day, in 365 days it comes as 2190 hours, and in a year we are spending 500 rupees as our repair or maintenance cost. Here we see that we find it as 0.23 rupees per hour. So the total fixed cost accumulating all these things, that depreciation, the interest rupees per hour, and the repair cost in rupees per hour, we see here 1.03 plus 1.26 plus 0.23 rupees, and making it as 2.52 rupees per hour. So what will be the operational cost? Here we see that for the operation, two very important things are the dung and thereafter the labor. So for the dung, we have already discussed that 25 kg of the dung will be needed on daily basis. So if we are calculating it as 1 rupees per kg of dung, that costing, so here we see that 25 rupees per day will be invested. So on daily basis, if we are treating it as 6 hours per day, then we can say that the 4.17 rupees per hour will be needed for operating this biogas plant. If we talk about the labor cost, here we see that 1 hour per day for dung collection and maintenance at rupees 20 per day. So here we see that 20 rupees per day we are taking, and ultimately for the labor cost we are not considering to hire any labor, but the family person can also invest their time for running that biogas plant. So ultimately we can say that 20 rupees, putting it 20 rupees in 6 hours. So coming it as 3.3 rupees per hour. So ultimately the total operational cost per hour basis, we can say that 4.17 rupees and 3.33 rupees, making summing it like comes as 7.50 rupees per hour. See the total running cost, which include the fixed cost and operational cost. Fixed cost, which were including the depreciation, the interest, and thereafter the maintenance, and the operational cost, that was including the dung cost and plus labor cost. All these things on combining, it comes as 2.52 rupees at fixed cost and 7.5 rupees as operational cost, making it as 10.02 rupees as our total running cost. So now it's time to calculate our total output. Here we see that daily gas output will be 2 meter cube, what we have assumed earlier. So the total annual gas output will be 2 meter cube on daily basis. So on in 365 days, that is in a year, this will be 730 meter cube will be our annual output for the gas. So the cost per meter cube of the biogas will be the total annual cost divided by annual gas production. Means if we talk about the annual hours, we have already known it that annual hours is the 2190 hours, and the total annual cost on the basis of that one, like it was 10.02 rupees as we have already calculated, and in a year there will be 2190 hours. So ultimately we are going to get rupees 21,939 rupees. So if we talk about the per meter cube costing, it will be coming as 30.05 rupees per meter cube. So the cost of our gas is 30 rupees around per meter cube. And the economic benefits, if we talk about, here we see that 1 meter cube of the biogas replaces around 0.5. Here you can see it clearly that 1 meter cube of the biogas replaces around 0.5 kg of LPG. And if we are treating LPG cost around 1200 rupees per cylinder, which is containing 14.2 kg of LPG, then you can see that 84.5 rupees for per kg of LPG. So saving of per meter cube of the biogas is around 0.5 kg into 84.5 rupees, making it as 42.25 rupees. So what will be the annual saving? So annual saving, if we talk about, then 730 meter cube what we have produced in a year, and 42.25 rupees we are saving. So ultimately we are going to save around 30.842 rupees at last. So what will be the payback period? Payback period is the installation cost by annual saving. So installation cost, as we remember that it was around 50,000 rupees. 50,000 rupees was our installation cost for our biogas plant, and we have saved this much amount, that is 30,842 rupees. So it will take around 1.62 years. It will take around 1.62 years. So roughly we can say that in 2 years we can pay all our investment on that biogas plant in 2 years. So costing that per meter cube of biogas is around 42.25 rupees, and the annual saving is around 30,842 rupees, and the payback period is roughly, you can say either 1.6 years, or you can say just 2 years will be sufficient for paying back all our investment, all our expenses which has been made for installation of that biogas plant. So ultimately we see here that the biogas plant installation as well as their running cost is beneficial for us, and also we can ensure that the animal waste and agricultural waste can be utilized in a better way. Here we can see that the dung and the agricultural waste and some kitchen waste and some urinary excreta and some waste material of our animals of our dairy farm is a very big problem to dispose of them. So if we are using the biogas plant like this, then not only it can be benefited for our energy demand, and it can also be benefited for disposing our animal waste, and we can manage it properly. We can get the manure out of it, which can be put into our field and making the soil with a better health and better crop production. Thank you.